Dear students, I am Santhan, working as a physics faculty in Target English Medium School. Today, in this part video from the chapter of laws of motion, we discussed what is the change in momentum and rate of change in momentum. About that one, we discussed about some ideas based on this particular topic in the chapter of laws of motion. So, in our previous video, I clearly explained what is momentum or linear momentum. How many types of momentum are there? Two types of momentum. One is the linear, another one is the angular. Linear momentum we are also called as momentum. Why? Because of means when a body is moved in the one-dimensional motion, either is nothing but it is either in horizontal or only in the vertical. Means if a body is in only one-dimensional motion, it has some momentum. Because of if a body is in the motion, it has momentum. If a body is in the rest, it has no momentum. That is, you know that very clearly. That's why if a body is either if a body is in one-dimensional motion, it has the momentum. That momentum we are called linear momentum. But if a body is moving in the two-dimensional motion, is nothing but if a body move in a circular path or in a curved path. During that type of condition, you are considered the radius of the path also. That momentum is called angular momentum because of the position of a body is changes with respect to the angular displacement. Due to that reason, we can say that when a body is in the two-dimensional motion, it has which momentum? Angular momentum. When a body is in the one-dimensional motion, it has which momentum? Linear momentum. What is the formula of linear momentum? P is equals to mv. This is the linear momentum. And what is the angular momentum? It is the linear momentum formula. Angular momentum is capital L is equals to mvr. Here, what is the difference you are observing? That m means mass, v means velocity. Here also, m is the mass, v is the velocity. But which term will becomes extra? Only the r. R is the radius of the curvature or radius of the circle. That's why. So, when a body is in the one-dimensional motion, it has which momentum? Linear momentum. When a body is in the two-dimensional motion, it has which momentum? Angular momentum. Now, we discuss that what is the change in momentum. This topic is helpful to us during Newton's second law of motion. That's why first we discuss about this concept. Let us consider a body of mass is m, initially move with u velocity. Listen very carefully. So, you know that when a body has the momentum, if a body is in the motion, it has the momentum. Our topic is which one? Change in the momentum. Momentum is nothing but the body must be in the motion only. That's why a body of mass is m, initially move with u velocity. Now on the body, a force will be applied up to t time. Then you are observing that this F force will be applied on the body in the same direction of the body. That's why you are observing that the body velocity is changes and move with v velocity. So now here you are observing that what is the initial momentum of the body here. And also, what is the final momentum? Once again, listen very carefully here. So, a body of mass is m, move with initial velocity u. now on that body, a force will be applied up to the theta in the same direction of the body. Then you know that the velocity of the body is changes and move with v velocity here. So what is the initial momentum of the body? Initial momentum means simply I said that before apply the force. Final momentum means after application of the force. Simply for understanding of that, before means when the velocity changes, you know that if the applied, if any external force is acting on the body in the same direction or in the opposite direction of the motion of a body, then its velocity is changes because of, and okay, in 8th standard level in the chapter of force we discussed very clearly one point under what are the changes produced by the force. A force can change the speed or velocity of a body. Is it correct or not? That's why here is also velocity is changes means what is the main reason? Force applied on the body. That's why. So before application of the force, that is called initial momentum, and after application of the force, velocity is change. If velocity change means momentum is also change, because of momentum is nothing but the product of mass and velocity. Here, the mass of the body does not change. For example, in a football match, a football is already motion on the ground with u velocity. Now, any player will be kick the ball. Then what will be happen? Its ball is move very fastly. So means mass of the ball does not change. What is change? Velocity is change. Already I said that. So the mass of a body is constant, but which is not constant velocity. That's why you are observing that if velocity is changed, momentum is also changed. So when the velocity changes after apply the force, that's right. So before application of the force, the body has the momentum when it is in the motion. That momentum we are called initial momentum, and after apply the force, its velocity is changes. Is nothing but momentum is also changed. That is called final momentum. That's why according to the diagram. So before apply the force, the body mass is m and move with the u velocity. That's why it is gives which one? Initial momentum. Because of momentum is nothing but mass and velocity product. The product of mass and velocity. Here m is the mass and velocity is what is that one? U. That's why the initial momentum of a body is mass and initial velocity. Now, what is the final momentum of a body? Means about this one. After applying the force, it is the final momentum. So, momentum is nothing but the product of mass and velocity. M is the mass of the body, and what is the velocity? V. So, initial momentum of the body is mu. Final momentum of the body is mv. But what is the change in momentum? Change in momentum is equals to what you can write means final momentum minus initial momentum. Final momentum minus initial momentum. So that is equals to what is the final momentum? mv minus mu. So this is the formula of to find which one? Change in momentum. So here in this formula, which is the common factor? M. That's why m of v minus u. So the change in momentum, we can write mv minus mu. What is the formula of change in momentum? Final momentum minus initial momentum. That's why mv minus mu or m of v minus u. This is the formula to find how much momentum is changes during the motion of a body. Next one is rate of change in momentum. Same concept. A body of mass is m, move with initial velocity u. Now on the body, if force will be applied up to t time, then the body velocity is changes and move with v velocity. So listen, a body of mass is m, initially move with u velocity. That's why it has some momentum. That momentum is called initial momentum, mu. Now on the body, if external force will be applied up to the t time, then the body is moving with another velocity, that is the v. That's why the momentum of a body after apply the force is mv. This is called final momentum. But what is the mean of rate of change in momentum means? So here rate is nothing but simply we can say that time. So rate of change in momentum is equals to change in momentum upon time. This is the formula to find the rate of change in momentum. Means rate is nothing but what I said that you can set the time. So means so the momentum is changes. Why the momentum is changes? After apply the force. How much time? T time. That's why you can set the time also. Means the momentum of a body is changes with respect to the time. That is what is the term rate of change in the momentum. That's why what is the formula? Change in momentum means we know that mv minus mu means final momentum minus initial momentum upon time means t. Or it is also you should be right. Okay, or sorry here only you can write or that is equals to m of v minus u upon t. That's right. The formula of rate of change in momentum is m of v minus u upon t or mv minus mu upon t. This is the formula to find rate of change in momentum. So listen students, in this time we have discussed 2 or 3 numericals about change in momentum. Means how we can solve the numericals when they are asking the based on which concept change in momentum. So first one simply find the change in momentum of a body of mass is 6 kilograms and its velocity changes from 5 meters per second to 15 meters per second. Listen very carefully. You can find the change in momentum of a body of 6 kilogram mass. Its velocity changes from 5 meters per second to 15 meters per second. So means according to the question numerical 1. A body of mass is m. We know that what is its mass according to the numerical 6 kg. Initially, it is moved with 5 meters per second. What they are given that? Okay, find the change in momentum of 6 kg mass of a body. Its velocity changes from 5 to 15. So, when the velocity changes, we know that after apply the force. That's why 5 is the initial velocity and 15 is the final velocity. So then consider that it is the m. What is the mass? 6 kg only. And after apply the force, F force, its velocity is 15. V equals 15 meters per second. So that is the way of that one. That's why here first which values they are given? You are observing that m value is given. Mass of the body is 6 kg. Initial velocity u is 5 meters per second. And v is final velocity 15 meters per second. So I said very clearly to everyone in the previous video what I said during the numericals when you can can solve that, but when we can find the answer by using the suitable formula, first we can check, okay, whether the given all the physical quantities are in the same system of unit or not. Now here all are in the same system. That's why what is our formula? Change in momentum. Sorry. Change in momentum is equals to m of v minus u. That is formula. mv minus mu or m of v minus u. We can use any one of the formula. So m is the mass of a body. What is the mass? 6. V is the final velocity 15 minus 5. That's why 6 into 15 minus 5, 10. That is equals to 6 into 10, 60 kilogram meter per second. So means how much momentum of a body is changes means 60 kilogram meters per second. This is the way of method to find the change in momentum. Next, another one. It is required to increase the speed of a scooter weighing 80 kgs from 5 meters per second to 25 meters per second in 2 seconds. What is change in momentum? Listen very carefully. It is required to increase the speed of a scooter. It is required to increase the speed of a scooter. Mass is 80 kilograms. Weight is nothing but 80. Mass is 80 kilograms from 5 meters per second to 25 meters per second in 2 seconds. What is the change in momentum? So in the second one, you are observing that mass of the scooter they are given, that is 80 kilograms. Okay, and its speed is changes from 5 meter per second to 25. 5 is nothing but initial. That's why initial velocity or speed is 5 meter per second, and final velocity is what is that one? 25 meters per second. How much momentum is required? So question is listened very carefully. To increase the speed of a body from 5 meters per second to 25 meters per second in the 80 kg mass of the scooter, so the force will be applied up to how much time? 2 seconds. Then during such condition, how much momentum is changes? Okay, a force will be applied. Listen very carefully. A scooter of mass is 80 kg. It is initially moved with 5 meters per second. On this scooter, a force will be applied up to 2 seconds. Then its velocity is changes 25 meters per second. Then find how much momentum is changes after applying the force. That is our concept. That's why change in momentum is equals to, what is the formula? M of V minus U. That is equals to, what is the M value? 80. What is the U value? 25. What is the U value? 5. That's why 25 minus 5. 80 into 25 minus 5, 20. 8 to the 16. 1600 kilogram meter per second. So how much momentum is changes when a force will be applied on the body up to 2 seconds, means 1600 kilogram meter per second. That momentum is changes in a scooter of weight how much one? 80 kilograms. And one more numerical, third one. A body of mass is 20 kilograms. Sorry, 500 grams hits the wall with a velocity of 20 meter per second and rebounds along its same path with same velocity, then find the magnitude of change in momentum. Here listen very carefully. It is a wall, we can say that. A ball of mass m is there. What is its mass? 500 grams. Listen very carefully. A ball of mass is 500 grams. It will be hits the wall with a speed of 20 meters per second. So now this ball will be thrown towards the wall. Means you can take a ball. The ball of mass is 500 grams. It will be thrown towards the wall. When the ball will touches to the wall, we know that according to that one, after touching this wall means the body. Yeah. So when you can throw a ball towards the wall, it is in the motion or not? The ball is in the motion with how much velocity? 20 meters per second. So that's why here on the ball no external force is acting except you. Okay. So that's why what is this one we are called initial velocity. A ball of mass is 500 grams. It will be thrown towards the wall. At that time the ball is moved with 20 meters per second. With the help of this speed, it touches to the ball and rebounds. We know that like the same concept. So if you can release the ball onto the horizontal surface. After fall onto that one, it will be rebounds or re-back in case of vertical mode. That's why when the ball will touches to this one, it will be bounce back, bounce and come back into the same path with how much speed? 20 meters per second. Here you are observing that when you can throw the ball, after touching to the ball is applied some force on the ball or not. That's why the ball will come to the reverse path. So this velocity is v. Here you can say as minus y for the initial velocity of a body or the direction of the motion of a initial body. It is in which direction? Opposite direction. So that's why during this type of condition, what is the change in momentum? So what is the mass of the body? 500 grams. What is the initial velocity? 20 meters per second. What is the final velocity? 20 meter per second. It is in which direction? Opposite direction. That's why minus of 20 meter per second. Here the minus is represented only the direction. Listen very carefully. Generally magnitude does not have any negative value. It is always positive value. But this minus is represented, this symbol, it is in opposite direction or other direction from the initial. That's why initial direction is towards the east and after touching to the wall bounce back and come into the west side direction. That's why the minus is represented only the direction. But according to our concept, what they are find out that you can find the magnitude of the change in momentum. That's why you are not considered the minus. Are understanding or not? You can find only the change in the magnitude. That's why I will take the 20. Are understanding? Okay, minus 20 I consider finally. Now come to that one. So mass u, v, three values are there. You know the formula of change in momentum, m of v minus u. M value is there, u value and v value. But you are observing that here is any changes are there. So u and v both are in the SI unit, but mass of the body is a CGS unit, means 500 grams. That's right. First I say that this is converted into the SI system. 500 by 1000 kg means 1 gram is equals to 1 by 1000 kilograms. 1 kilogram is equals to 1000 grams. Then 1 gram is equals to 1 by 1000 grams. Is nothing but okay for understanding. So that's why zeros, 2 zeros get cancelled. So 5 1 5 2 that is equals to 1 by 2 kilogram or 0.5 kg. That's why what is the mass of the ball? 0.5 kg or half of the kg. Now change in momentum simply that is equals to What is the formula? M of V minus U. What is the M value? 1 by 2 kilogram. What is the V value? Minus 20. And what is the U value? Minus 20. Means minus is there, minus here. U value is 20. That's equals to half. Okay. Minus 20 into minus 20, minus 40. So 2 on the 220. That's right. Minus 20 kilogram meter per second. Here I say that this minus is represented the magnitude, means how much momentum is changes, means in the opposite direction 20 kilograms per meter square. But okay, so only they are asking the magnitude, that's why you are not considered the direction. Then what is the answer? 20 kilogram meter per second. So this is the way of the method to find the change in momentum when they are asking this type of mode.